Well, good enough. Okay, yeah. Test from our tech shop, Detroit. No. Yes, today is coffee. We're here to do some testing to show what the tech shop had about in Detroit. I don't know where the audio's gone. This is only a test. Let's get the audio cranked up here. That's better. We're coming better at audio right now. It takes a little bit of testing to see how this works.
Sir, if you'd like to use laser 3.
Back up?
Back up.
Awesome. Thanks.
Yep.
Sorry. Nice to meet you.
Complicated.
Okay. I'm glad it wasn't just me.
I just want to have a quick update on my Saving the Bees project. The vision here is to make papers working independently beekeepers to bring affordable electronic technology to the current beekeeping practices. And last time I presented this at the open house. The idea of having a thermometer probe embedded in the boxes and a portable unit that can.
Competitions in Germany, Austria, Italy, Australia, Russia, all through different places. There's also one actually this week in Nebraska that we're getting ready for. That's why you don't see the car here now. It's actually being worked on back at the shop to get ready for this week. So yeah, we have another competition coming up. It's not quite as big as this. There's only 80 teams, but nonetheless still it's a sanctioned event, and we'll have a pretty strong competition. Anything else? Slides? Anybody has questions?
Is there any crosstalk between you and Ann Arbor team?
Not a whole lot.
We spoke to a couple other guys there for a competition. We're pretty friendly between schools, especially when the competition's over. Like we were all at one campsite. We were talking to them, and they actually invited us out to go look at their shop one day. But we really don't talk to them much during the build season because they are their own separate team and are competing against us. So yeah, they're pretty much our biggest rivals. They're usually the top 10 team.
Yeah, so, yeah.
They're eighth place this year. So. Our powertrain is completely different from theirs. A lot of
It's the beauty of the competition. There's a lot of different ways to approach the same problem, right? So you have all these different designs that show up. They have a really big aero package this year. They do the first year, and they also have one like I would say the 4-cylinder drivetrain. So yeah, there's many different teams that run different style setups. There's teams that run single-cylinder dirt-like engines, 450cc engines, and with no aero or with really big aero as well. And it's it's impressive the diversity you get in the cars that you see in competition, all the different ways to solve the same problem. So it's kind of cool.
The beauty of the competition is the rules are in place primarily for safety precautions. For instance, the chassis is able to withstand certain impacts. God forbid somebody hits something. And there are rules that restrict, for instance, like the footprint of the car, because they don't want you making like a Miata or a go-kart. They want you to make something that looks kind of like that. But the kind of like that is a very, very, very open realm. You have cars that come with big wings, little wings. You have cars that come with crazy innovation projects that other racing series don't allow. Because you look at Formula One and somebody who's not really that attuned to it, like, all the cars are the same. That's true. Most of the cars do look all the same. But that's only because that's been
competitions in Germany, Austria, Italy, Australia, Russia, all through different places. There's also one actually this week in Nebraska that we're getting ready for. That's why you don't see the car here now. It's actually being worked on back at the shop to get ready for this week. So yeah, we have another competition coming up. It's not quite as big as this. There's only 80 teams, but nonetheless still it's a sanctioned event, and we'll have a pretty strong competition. Anything else? Slides? Anybody has questions?
Is there any crosstalk between you and Ann Arbor team?
Not a whole lot.
We spoke to a couple other guys there for a competition. We're pretty friendly between schools, especially when the competition's over. Like we were all at one campsite. We were talking to them, and they actually invited us out to go look at their shop one day. But we really don't talk to them much during the build season because they are their own separate team and are competing against us. So yeah, they're pretty much our biggest rivals. They're usually the top 10 team.
Yeah.
So, yeah.
They're eighth place this year. So. Our powertrain is completely different from theirs. A lot of
It's the beauty of the competition. There's a lot of different ways to approach the same problem, right? So you have all these different designs that show up. They have a really big aero package this year. They do the first year, and they also have one like I would say the 4-cylinder drivetrain. So yeah, there's many different teams that run different style setups. There's teams that run single cylinder like engines, 450cc engines, and with no aero or with really big aero as well. And it's it's impressive the diversity you get in the cars that you see in competition, all the different ways to sell the same product. So it's kind of cool.
The beauty of the competition is the rules are in place primarily for safety precautions. For instance, the chassis is able to withstand certain impacts. God forbid somebody hits something. And there are rules that restrict, for instance, like the footprint of the car. So they don't want you making like a Miata or a go-kart. They want you to make something that looks kind of like that. But the kind of like that is a very, very, very open realm. You have cars that come with big wings, little wings. You have cars that come with crazy innovation projects that other racing series don't allow. Because you look at Formula One and somebody who's not really that attuned to it, like, oh, the cars are the same. That's true. Most of the cars do look the same. But that's only because that's been honed and there are rules that say this has to be the same as this and this and this, and there's so many spec parts. And for us, we don't really have anything like that. They let us run wild with creativity, and it also really lets the students show that they can take a proper design path and say, well, this is what we want to achieve. These are our resources. This is how we could do it, and then have a lot of people field ideas and essentially compare them all like a proper engineer would. So it gives you more design freedom while also testing your limits.
Like you were saying with the different cars, there's teams that run a complete carbon fiber monocot for the frame. Most teams run a tubular space frame. And then this year, Tennessee Tech showed up with a block of a frame car. It was all large-ended square pieces that were bent a little bit. It was really interesting. And no other team.
Yeah, the whole panel just wired into a 16 monitor.
It was crazy.
But it just goes to show the creativity that people put into it really pays off, and sometimes it can just as easily pay off, and sometimes doesn't, and they end up with a flop.
It's amazing how little the actual quality of the design matters. So you could actually have a really bad design. No, I'm serious. You could have a really, really bad design, but the important part is actually getting it done. So getting it done, having facilities to make it, and getting it done in a time that matters so that you can test to make sure that you get through all the events like endurance and all the racing. So if you don't have a good design, but it's really well tested, and you have a lot of time, you have people that are comfortable in it, things like that, it generally outshines good designs that are poorly executed.
The top 3 designs this year didn't finish in the endurance event. So
Yeah, the top 3 design panels didn't finish it.
It just kind of, like you speak to anyone who's just joining a team like this, they're all excited, like, oh, it's a racing team. If you speak to anyone who's been on a team at least a year, they say, no, it's not. It's a time management project.
Yeah.
Because if you can design the most amazing car, you can take an F1 car and scale it down and make it fit all the rules and be the fastest car out there. But if you have never driven it and you finish putting the last bolt in on your way to getting in line for the competition, something always goes wrong, and you probably won't do very well. So getting the car done really hinges on how well you do it. And that's why it's nice having a place like this where we can actually have resources to get the car done on time. For instance, last year we used our TechShop memberships for the first time, and we did pretty well in terms of getting the car ready. But this year we had more people working on the car, more people building things, and just a greater enthusiasm and a bigger team. And we ended up actually having about a week before the competition, opposed to last year where we had maybe a day. So it was
negative 1 day.
We didn't have an hour.
Yeah. The day was coming.
Yeah.
I think we have a question.
Yeah, so I'm assuming SAE is Society of Automotive Engineers, right?
Yes.
Okay. Now, do you guys get, like a compound question, do you guys get a mentor who's like an SAE sort of member affiliate engineer helps you guys?
So what we get is a faculty advisor. So it's a professor at the university who kind of oversees our operations. They don't do a whole lot of other starts to do a whole lot of hands-on stuff with us. We're mostly left to our own devices, so we don't have a whole lot in terms of that. We do have a pretty strong alumni base. This is actually our 20th anniversary card, so we've had a Formula team for 20 years. So obviously after Formula, it's generally lends itself to getting a job, right, as an engineer. So we actually have a pretty strong communication base with our alumni, and we're pretty well all engineers. It different auto suppliers around the area. So a lot of times if we have technical questions, things like that, we tend to go for our alumni. And it's also a pretty big farm, and we're, 9 times out of 10, you're not the first person to have this problem. So look these up, trying to do some research and that sort of thing too.
And then, what other competitions are they going to Nebraska? But where else are you guys taking this car in particular?
We are looking to go to actually a non-sanctioned event. The University of Toronto holds what they call a Toronto Shootout every year. They go to Mosport Park. They used to race Formula 1 there back in the 70s. And they have this 1 kilometer go-karting track on the side where people bring their 125cc shifter cars, things like that. And they actually invite 20 teams out. And it's just, with our sanctioned competitions, there's our cost analysis and our design analysis and all this. At Toronto, it's much more relaxed. It's just a tech inspection, and then the track's open. So everyone's a lot calmer. It's not so cutthroat per se. So it just gives teams to throw their cars up against each other, see who does the best, see what drivers are nice and fast. And last year we had a lot of rain actually, so that threw another little element in there. So we're gonna try to take it there at the end of September.
We also use it to do testing for our 2015 build, so we try different things that we may or may not make the car faster, so as we have something that's working test that, test a new ones, we'll try new things.
And then last question, sorry. What are the different elements of the competition? You said there's endurance, there's a time trial on the same day.
So it starts off with a tech inspection, day one. So this Tuesday morning, we're going to leave, go to Nebraska. We'll wake up Wednesday morning, 8 a.m., pick a number, get a paddock, and you get in line for tech inspection. So you go through all the tech inspection. They have this huge list that they go over everything on the car, right? That gets you through that. Then you have to do, all your drivers have to do egress. So every driver has to be able to get out of the car in 5 seconds when they're fully strapped in. So you have to get out of the car within 5 seconds. All drivers have to go through that. You have to pass through your template, so make sure the chassis fits the cockpit template. From there, you're moving into the following day where you do noise tests, you do tilt, so they fill up the fuel, tilt you at 60 degrees to make sure you have no leaks. And then you do brakes. You have to get a running start, and I forget what the distance is. It's not too far, maybe about 50 yards. Get a running start, and then you have to stop within a box and lock up all 4 tires. Then you're ready to beat dynamic events. Dynamic events start the following day on Friday with acceleration and skid pad. There's 75-meter straightaway, and then there's a 50-foot diameter skid pad that you go around in the kind of. Then later in the day on Friday is an autocross run, so it's just a bunch of cones set up on a big concrete pad and drive the autocross course. And Saturday all day is endurance, so it's 22 kilometers, 10 laps per driver, 2 drivers. And it's the whole day. And, I think this year there was a 60% attrition. Only about 40 cars took the checkered flag at Michigan. So yeah, a lot of teams didn't make it. There was a few teams that caught on fire, a few teams that they both spun out and hit the wall. Yeah, it's pretty. Yeah, Saturday is a really big day. The endurance event's worth actually 40% of the points. It also has the fuel economy event built into it, so the amount of fuel they use is also supported.
There's also step events.
On top of all the dynamic events, we have the static events, which we do cost analysis. So it ends up being a book like this that with a ton of spreadsheets that do the cost of every nut and bolt on the car, or at least supposed to. And then there's a business presentation trying to sell it. So if anyone's ever seen like Shark Tank, it's exactly like that. We're trying to sell it to 3 judges. And then there's
Because the whole premise of this thing, right, this competition is to build a car that a weekend warrior will want to autocross on. So that's why they do it.
Yeah. And then there's a design event where we have to prove to engineers out in the field. Usually they're fairly high up and know what they're talking about, so you can't really pass anything through them. So all your designs and everything.
Every subsection actually ends up with their own judge. So you spend actually about 20 minutes talking one-to-one or two-to-one to somebody who's essentially made a living for the last couple of years, or 10 years, 20 years, doing everything that you tried to do in 1 year. And they will nitpick and they will look at everything you've done, and the more data you bring them to say, like, this is why I did this, and this is why I didn't do that. they like things like that. They don't really like you saying like, well, it looks cool, so whatever. They don't like stuff like that. So it actually gives you a chance to gauge your own capabilities against what somebody might expect of you. There have not been any injuries in the competitions. There have not been any serious injuries in the competitions around the world. But unfortunately, one team, I think almost 10 years ago, actually 5 people died on their way to a competition because they were improperly towing their trailer and they got into an accident. So things that you wouldn't even think were relevant, like driving to competition for us is a 40-minute, 50-minute drive out into the country, but some people, they drive cross country, things you would never expect might happen.
So this took you 1 year to complete?
We started, so we got back from the last competition. We spent, I don't know, 2 days sleeping, and then we got back to testing. We set up the actual old car with a whole bunch of instrumentation, wheel speed sensors, shock potentiometers, potentiometer that'll record which way the steering wheel is turned and how much, things like that. And it'll actually gather all engine parameters and it'll log them versus time, and you can go in there and read like, well, at this point in time, this is what was happening, this is what the driver was doing, and then you can overlay that to like whenever we were driving, like say we were doing like a skid pad, like just driving a circle.
Has GPS built into it, so they can bring up your GPS map and see what's happening in this corner, that corner, to see how one driver is faster than the driver in this corner, that corner. All on a GPS plot versus position on the track as well as time.
So we used all this data to try and figure out what that car was doing, and based on that, how we want to change. For instance, that's actually how we started our aero design. Was we decided that at this point in time, going through this corner, we could be so much faster if we made this amount of downforce. And then data like that is what eventually develops into, well, what am I going to design? How do I want to change this car? What will make us faster? And so essentially the entire summer, we try to spend as much time as possible in the testing phase. And then basically the fall semester is spent designing, and then the winter semester is spent building. That's the basic breakdown. But we try to spend as much time as possible on this year round.
I think in the total of 20 years that we've been doing this, I believe there's only been 3 years where a car has not been produced.
No, it was like 2 years. One that was very close.
So what's the cost
Of the car or the program?
to build the car?
To build the car, I guess,
Things like operating budget, I think.
yeah, if we usually operate on about $35,000 in terms of liquid cash, which is at our disposal to build the car every year. But in the terms of all the sponsorships that we get, help from outside companies, they just don't charge us for some of the services that they provide, or they provide us a reduced rate. That orders on the like $75,000 range, but then in total of the licenses for all the software that we use, that gets up to about the $200,000 range.
But you also have to think that the companies who make this software, they put so much time and effort and money into their R&D, but as soon as it's made, it doesn't cost them anything to give us, a 70-character string of text that we put in and use our own software. It doesn't hurt them at all. And they're eager to help us with something like that, because then if one of us goes off and works in a company, and like for instance, Sean and I are doing computational fluid dynamics. One license to the software is $7,000. Yeah, that's a stupid amount of money. You can go out and buy a BMW for that, but you don't. You buy the software. And if I go out and work at a company that asks me, like, well, we're doing this project and we need to do CFD, then they're going to say, well, do you already know how to use anything like that? So it's to the company's advantage to have us learn something, that we familiarize ourselves with something that we can later go on and say, like, I like this software and I know how to use it, we should buy it. So that's where they can also gain another advantage in terms of making money.
So to answer your question, how much does it cost? It's hard
A lot.
to answer. If we actually have to do it with everything, like.
You did some cost analysis you mentioned earlier.
So,
That package,
yeah, within that
what
package,
really you did?
they give us a ton of tables to follow through SAE between processes, materials, parts.
Dog Day, you know, those of you who know me, I will find any excuse I can to retreat to this place. Like, I just love it. So, no national day, we just like having hot dogs and it's still beautiful outside. So while we can still enjoy the sunshine, we're gonna have another barbecue. So please join us. The price of admission is aside. We'll provide hot dogs and drinks and all the condiments that you can want. Then next week, movie night, we're watching Wall-E. So that'll be fun. Yeah. While I bring popcorn in here, bring the kids, it's open to anybody, you don't have to be a member. Then a whole other set of things, intellectual properties workshop for members. If you have a patent idea, that's going to be on the 17th. We have an attorney from the Doberson law firm coming in to talk about how you can protect your intellectual properties, work on new patent ideas, and sort of answer any questions that you might have about that process. Then the 20th is our Ladies' Night meetup. That's it's open to the public, so anyone can come. It is Ladies' Night, but I always like to say you can also bring the inner lady in you. Gentlemen, you're welcome to join us if you feel absolutely, inclined to, but it's a nice place for lady makers to meet and mingle and talk about what they're working on. And currently, they're working on a charity project making hats that are going to be distributed in the city for less fortunate kids. So, if you have either fleece that you'd like to donate to their cause, or time, or you're just interested in seeing what they're doing, stop by on the 20th. Then we have our textiles meetup on the 23rd. And finally, we're having an ice cream social again. Food, yes, I love it. On the 26th, so ice cream, we'll have some toppings, and if you bring something to share or not, because I'm not going to judge. That's fine if you want to order chocolate syrup, I get it. So, but as far as today goes, we had 3 presenters lined up, and unfortunately, one of them wasn't able to make it today due to a medical emergency. Everything's fine, but she's not going to be here, so hopefully another time we'll get to hear from Ms. Marianne. But today, stay lives, as it were, primarily in California, but now here as well. And then afterwards, we'll be hearing from Sean about the new 3D printer. And of course, Sean is our facilities manager here. So he's going to talk about how we got here, why we changed it, why we have this new one, answer any questions, sort of how it's going to end up working together with classes, things of that sort. And then, did I hear a surprise presentation about graphene, perhaps? So, yeah, I didn't know what it was either. It's okay. It's pretty cool stuff, though. So, we can please welcome Mr. Ara up here. He'll get us started today.
Thank you. As Ashley said, I'm in graduate school for design, and my background in design has been primarily fashion, not only styling but also in designing. And in Los Angeles, I work with artists, primarily performers, and a lot of the work I did revolved around performance. And before deciding to go to graduate school, sorry, Ashley. I'm sorry, just one moment. A lot of the pieces that a lot of the design work that I was doing was primarily costume. A lot of imaginative sort of fantasy pieces. And that led to something a bit more refined. And I started doing a lot of work that required pattern making. And pattern making sort of became an obsession. I found that curved forms fit our bodies best, and completely strayed from the conventional route of pattern making that typically revolves around straight lines and right angles. Given that I don't have a formal background in pattern making or design in general, I kind of just winged it and found that this method accommodated the body better. And I was translating a lot of the paper patterns to fabric, and it sort of branched off into larger pieces, like this gown, and the vest at the top, and it's the jackets. I did some sculpture work as well to sort of further investigate curves, body, at Cranbrook, I took that apparel design concept and translated it to furniture. So this is a slipcover for a cast chair, which I found to be extremely boring. I've never really had a normal desk job, and I never really sat in a sort of a desk chair. And we were given these cast chairs, which are great chairs for what they are. Just for me, it was like a visual affront, and so I had to more or less weave a web about it to make it comfortable visually. And I branched off from this point into doing another piece. Now this was just in my dorm. I took apart an old dorm chair and kind of stood it up on boxes, and really I was just playing around and creating a new pattern for this frame, really, but without the intention of having it stay on the frame. I wanted to make a freestanding chair out of solid material, and I really had no concept of where that was going to lead in terms of material or the process by which it would come together. I just kept building this model, this full-scale paper model, and my department was really freaked out. They were like, what is going on? And I couldn't even really answer that question. This summer I decided to stay behind and stay in Detroit. And actually I discovered TechShop and got a membership here and started working at TechShop. And this was a failed sheet plastic model that I worked on actually before I got to TechShop. I was just doing a lot of reading and research, and in the meantime I thought, I'll just keep my hands busy, and I made this scale plastic piece, which at this point is just like odd decor on my apartment. And at TechShop, I essentially scaled the model down to miniature form and started just working with finishing the piece, learning more about the design itself, what worked, releasing tension from some of the joints, and then I began working in a heavier material to see how that would play out. And all the while, there was a great deal of research going on in terms of material and process. I joined the Woodworkers Guild of Michigan by the suggestion of the guild itself, saying there's something here for you, and was put in touch with the man who really wrote the book on steam bending, Lawrence Schlesing, who essentially told me this could not be done in a steam bent wood. And that was just one sort of episode in a never-ending story of research and finding dead ends everywhere I went. I didn't know how I was going to make this piece until maybe just recently when, I like to play with the pattern pieces themselves and sort of turn them into graphic sort of little images. Pattern pieces themselves sort of lend themselves to design, even in 2D. But in 3D, I found that Hydrotech, which is a green plywood, was the best option. A TechShop PC happened to pass them by while I was working on my models and said, hey, did you see the baby outside? And suggested that the boat-making material and technology would be well suited for my project. And I just jumped right on it, went out and bought materials, and took some experimenting. I essentially needed to curve cut the entire inside of the pattern pieces so that I was able to achieve the compound curve that I was looking for. And this is just a small segment, slightly smaller than the scale version of just two pieces stuck together using the stitch and glue method that I was introduced to in Virginia. And now I'm essentially waiting to do a full-scale model as soon as I have a CNC class under my belt, because I don't like doing this by myself. It's really hard. Cutting things on a curve is probably not what the bandsaw or the table saw or any of these sort of make nice saws are really good to do.
and life is like a song. Come on home.
I'm coming home, baby, now.
You know I'm waiting here.
I'm coming home now, real soon.
You've been gone.
I'm coming home, baby, now.
You don't know what I'm going through.
I'm coming home, I know I'm overdue.
Since you went away. Waiting now, real soon.
But I do. Return off the Mac. Return off the Mac. Come on. Return off the Mac. Oh my God. You know that I'll be back. Here I am. Return off the Mac. Once again. Return off the Mac. Talk about the world. Return off the Mac. My floor. You know that I'll be back. Here I go.
I am the passenger. And I ride, singing.
Hi, my name's Keith Burns. I'm from Collierville, Tennessee. I'm here today to turn a hollow form. I will start with the hollow form. After that, we'll do the lid and then the finial and finish it up with my 10-minute finish. One of the most important things is always remember safety. Always follow the instructions in your manual. And above all else, always wear a face shield when turning. Safety glasses, I wear safety glasses if I'm turning small parts like my finials. But anytime you're turning on a larger piece, always wear a face shield because lathes can hurt you. So let's get started. I'm going to start by getting this piece, although it's been cut, it's still out of balance, so we need to get it round. I'll start with the bowl gouge and see what I think of that. And I may switch tools, but I want to show you both ways and the differences between them. So I'll go ahead and get started. When you start your lathe, always start it slow because you don't know if that piece is way out of balance or in balance until you get it going. So always start slow in the beginning, and then you can speed it up to get it to a comfortable speed. Always remember that if you're not comfortable with anything, don't do it because that can get you in trouble. So I'll start with the bowl gouge and we'll see how that does. Now, as you could tell, there was a lot of chatter and noise with that bowl gouge. Personally, I prefer using a carbide cutter for hollowing. Always make sure that things are tight. That one is getting loose, which happens during roughing sometimes. So now I'm going to switch to a carbide tool and make it a little smoother, a little quicker. Now, as you could hopefully tell, there was a lot less effort on my arms and appendages. Still want to make sure everything's good and tight so it'll stay on there. So now I've got it round, so now I'm ready to switch back to my bowl gouge. And as far as form, there's good forms, there's not so good forms. The 2/3 rule I don't follow, I don't measure. The main thing is if you're happy with what you've come up with, that really is all that's important. Again, it's all about having fun. So now what I'm going to do is start working on the form itself. And whether or not you start with the top or the bottom, doesn't really matter. Now, there's several methods of mounting your piece to turn it. When you're mounting your work, probably the safest way, and I think most turners will tell you this, the safest way is to use a faceplate with screws. But sometimes you don't have enough wood to do that with, so I typically will use a chuck and I use a 2-spur drive center that mounts in my chuck. And what that allows me to do is size my tenon to fit my chuck. I don't have to measure anything. I don't have to worry about getting it too small or too big. And the width of the carbide cutter is the depth that I need in the chuck. So I'll go ahead and cut that real quick. Now this piece had an angle on it, so I need to make sure that I get to the low side of the angle to get my depth of my tenon, and I'll cut this off when we get ready to mount it in the chuck. So now I've got a perfect 90-degree tenon and the diameter that I need to fit in my chuck. So now I continue on. I know where my bottom can be, so now I'll continue on and refine my form. I'll also mention that I tend to turn pretty aggressively, I think, at a pretty high speed. Again, I say, if you're not comfortable doing that, slow it down. Always remember to adjust your tool rest. Keep it as close as you can to the work. Always spin your piece, make sure it clears. I'm going to get rid of that inclusion. Got rid of that, so I'll go back and refine my top a little bit. Another thing you need to do is not watch where you're cutting down here. When you get to getting your form down, watch the top of the form and you'll see where you're going to go with it. So I'm continuing. Okay, I think now we can switch and put it in the chuck. I've got my rough form, and when you remount it in a chuck, anytime you remount it, it's never going to be perfect, so there's no need in me getting this finished completely because it won't be perfectly round when I get it in the chuck anyway. All right, I've taken my piece to the bandsaw and I've cut off that angle part that was on the bottom of the tenon. And a couple of important things to remember is that you don't want the bottom of the tenon hitting the bottom inside of your jaw, and you want a good solid fit, flat fit of the jaw chucks on the outside of the piece. If you don't and it's in there and it's cocked, it's going to come out. Another thing I learned from a friend of mine is to make sure that your jaws are all the same height. If they're not, you can face them with a standard high-speed steel bowl gouge. This is soft steel. It won't hurt your bowl gouge. So that's another little trick that will help keep the piece in the tenon. So I'll mount it in there. I'll tighten it up slightly. I'll bring my center up, make sure I'm good there. Always use your center as long as you can on anything that you turn. So I've mounted again in the chuck. It's a little bit out of round, so I'll continue now to refine my form. I'll leave the live center in as long as I can because it does give you an added protection. So again, I'm just refining my form. And I can see already I need to take the top down some. It's a little too high for where I'm going to end up. Need to visualize in your mind. I'm running with the tool rest on the wood, not a good idea. Where you want to end up with your piece. So I think the bottom, I'll bring it down more to a smaller foot when I get to that point. But I won't do that until later. So I'm going to clean up the top a little bit, make sure I'm good there. Make sure I'm happy with Then once I've kind of got it to the shape that I want, you can turn the bowl gouge on its side and do a shear scrape with the opposite edge of the tool, and it'll give you a nice finished cut. And it takes off very fine curls, which is a good what you want to have, because that means you're getting a nice clean cut for the most part. So I'll take a look at that. That looks good. I had a little crack there. Well, I still have it. I think what I'll do is put a little super glue on that because I don't necessarily, you can cut it away. In fact, why don't we try that? Why don't we see if I can get rid of that little crack? It's not a big crack, but it may end up showing where it doesn't need to show. So I'm going to take that down some. It's called a design opportunity. and I still have it, so I may have to go deeper to get rid of it, but it's in a spot where it shouldn't show. But what I am going to do is add a little super glue to it, or whatever they call it these days, instant some kind of glue. Now that'll just help hold it together. And I'll turn most of that away, but it'll leave it, and I use thin glue, and I'll leave it, it'll remain in the crack, and hopefully won't show too bad. So and again, I'm doing that shear scrape with the bowl gouge. Yep, we'll do a little sanding on that, and should be good to go. So I'll continue to come on around. All right, I've basically got the top portion cleaned up and finished, got a pretty good finish on it, so now I'll move my tool rest and continue around the side. And lock the tool rest in and continue on. Now that's a little rough on that side because there was some tear out. And that we've got rid of most of it on that area. Alright, so I'm continuing to clean up around the final edge with that shear scrape cut with my bowl gouge. And it doesn't hurt to stop the lathe and look at where you're at. Sometimes it makes it easier to correct some problems that you're having. I had a little bit of tear out left. Went back, cleaned it up. I think I'm in good shape there. So I'll continue to come on around this side and always watching the top of the piece to see what my form's looking like, because it's not too late to change things now. Again, I'm using a shear cut with the bowl gouge, and you can hopefully see the very fine shavings coming off. Okay, I've ended up with a little ridge there I need to take off. It's easy to take the wood off, but it's hard to put it back on, so at this stage in the game, you don't want to make heavy cuts. So now I'm ready to go on down toward the foot, and I won't go all the way down because I want meat there to hold it while I'm hollowing it. But I can visualize where my foot's going to be, and I think I'm pretty good with my golden mean rule. Again, I don't measure it. I do it by eye. Alright, that looks pretty good. So now I've got that done. Now I'm ready to start hollowing. Alright, I've gotten rid of my tool rest. I've taken the center out of the tailstock, and I'm using the Carter strong bore to bore my center hole into my piece. I will either use a piece of tape to gauge how deep I want it. In this case, it comes out to one of the set screws, so I don't need a piece of tape. So always slow down for drilling. Use a Forstner bit, whatever size opening you want to put in it. If you put a smaller opening and it ends up being bigger, that's fine. I personally like smaller openings, so I'm going to go with that and see where it ends up. You always want to make sure to clean it out. Because it always makes that squealing noise. So I'll go ahead and start in. You can pull it out or use the handle to get it out. It's a lot easier to gauge your depth this way because you've got a point to go to that you know is not too deep. I always allow a little extra room at the bottom. Alright, I've reached the bottom of the piece. According to my guide I set up, and the thing that I really like about the strong bore is it makes it much easier to drill from a standpoint. I've used normal drill chucks, and the problem I have there is that they do work, but typically when I'm done and pull it out, it takes a pair of channel locks to get it undone. The good thing about the strong bar is it makes it easy to change your bit. With a normal drill chuck, sometimes that bit gets tightened in there. Takes a pair of channel locks to get your Forstner bit out. With this, there's 2 set screws, and you can change your Forstner bit. There's also additional pieces you can put here to make it any length you need to make it, so you can actually drill a 12, 15-inch guide hole in your piece. So now I think we're ready to hollow. Okay, I've got the blank mounted in the chuck. I've got the multi-rest and the hollow roller set up. Instructions for setup on these units come with the tools. There are also videos on Carter's website that give a quick demonstration of how to set up the tools. The multi-rest is by far the best value on the market for a steady rest. I use them on 90% of the work I do because it adds that safety factor, helps keep the piece centered. The multi-rest actually will fit any lathe from a 10-inch through a 24-inch, and I've turned on 12-inch lathes, 16-inch lathes, and 24-inch lathes with it. And it's great, especially if you've got more than one lathe. So the hollow roller is the easiest, smoothest hollowing system out there in my opinion. And I've used several different brands, and this one just takes all the stress, all the vibration, everything. It just makes it a whole lot easier and a whole lot smoother to hollow. So, all right, so we're ready to start hollowing, so I'll get that going and we'll see where we end up. Now, it's always important to keep the shavings cleaned out, otherwise they'll build up and you will end up having a catch. So I'm going to pull the shavings out. And it doesn't hurt during the process to check tightness on everything. I'll typically do it 3 or 4 times. I'll check my chuck, make sure it's tight, because occasionally things can work loose and cause issues. And you don't want issues. So I'll clean the shavings out. I'll get back to hollowing. Typically when hollowing, it's always best to work your way from the top down in sections somewhat, because you've got more mass down here to support your work. Again, clean the shavings out. And it does not hurt to use the laser when you're roughing it out, but I'm going to try to do it without the laser. Hopefully we won't go through the side. If we do, we do, but I don't think we will. But it doesn't hurt because it allows you to not go through the side. Now, as I've mentioned, I'm a pretty aggressive turner. Now, I'm always anxious to get a piece done. I don't have a lot of patience, as I probably should sometimes, so I turn aggressive. I like to get in there and get it done. I'm anxious to see the piece finished. But you don't have to do that. You turn at your own pace with what you feel comfortable with. I will show you that how easy this is to use and how little stress it takes to turn. I'm going to actually hollow with my fingertips, just to show you how easy it is. And you can actually do it with 2 fingers. The big problem with that is you don't have a lot of control over what you're doing, but it does give you an indication of how easy, how smooth it can turn, and how little stress it puts on your body. I've turned a manzanita root, probably 12-inch diameter, 8 inches deep with this system, and I didn't die from it. It made it doable and easy. I'm sure you all noticed, and I'll just point it out since I'm at that point. One of the things for those of you who have not seen this tool in action, you may wonder why this is so short, and the reason is because you don't need the extra length. If you need, you can set this hollow roller anywhere you want to on the lathe to help you with the position of your bar to get where you need to get. There I was hitting the edge of it, and I want to go farther that way, so I simply move the hollow roller out. Not quite that far, because you have to be able to get your tool in. And now I can slide it out there, and I can get my bar farther in on the outside of the turning. Okay. And typically, you'll feel when the shavings start getting too much in there. I can't tell you what the exact feeling is, but it'll begin to kind of bog up on you. Kind of start acting like it may want to catch. I try to get to it before that point. Okay, when I'm turning without the laser, primarily when I'm roughing, it does not hurt to use a set of calipers to help you judge where you're at and make sure that you're not getting too close to going through the side. And this one I've got a little over a ½ inch of wall thickness left, so I know I'm a good ways away from it yet. So we'll just continue the process. Okay, one more clean out, and I think it's time we go ahead and switch over to the swan neck bar with the carbide bit, and we'll go ahead and put the laser on that bar and go ahead and finish up the hollowing, and then we'll be ready to get the top ready for the lid, finish turning the piece, take it off, reverse chuck it, turn the bottom off, and then we'll be ready to start the lid. Now I've mounted the hook bar with the carbide cutter ready to finish up the inside. Already roughed it out with the straight bar and the carbide, or the high-speed steel cutter. I've got the laser mounted. To set the laser, the tool comes with a little card, which is very helpful, and you simply put it under your cutter, and the laser will hit, and at this point, this one is set at about approximately 1/8 of an inch. So basically, for those of you who are not familiar with lasers, what you do is this laser light, the tip of it is set, as we set it, approximately 1/8 inch off the edge of the cutter. So as you're cutting, that light will gradually move out, and as soon as it gets down to where it drops off the edge of the wood, you know you're at the wall thickness you need. Sometimes I may let it stay a little bit on the wood, depending, but that's how you can gauge your wall thickness. As you move around and cut in different sections of the turning, you will adjust that laser, which I'll show you that after we've gone through the first stage of it. And it's just a simple matter of a couple of set screws and making a couple of quick adjustments, and then you go on around and then down to the bottom. So where I'm going to start is on the top part of the turning, again to provide that extra support from the thickness in the bottom of the turning. All right, time to pull the shavings out again. I think you can see where the laser's hitting. I've still got plenty of wall thickness in there to get rid of. So we'll just keep taking it down, but I can't stress enough the importance of keeping the shavings out, because when they get full in there, it can really cause problems. Another little hint is always turn off the lathe before you pull your tool out. You can have a little slip of the hand and have that tool catch somewhere on the turning, either crack the top out, any number of things. The thickness that I've got it at the opening is, I can tell by looking at it, it's where I need to have it for my lid to be able to set in there properly. Yeah, we're there right there, so I'll go ahead and get this area down, then I'll readjust the laser for this so I don't go through the sidewall. out the shavings again. Now I've basically got the top done over to about right here, so I need to get the shavings out and readjust my laser over to the end of the tool so I don't go through the sidewall. Although I'm sure that a lot of people would enjoy seeing that, I don't particularly want to do it today. So we simply take that, move the laser out, tighten that little set screw up, and then move the laser out here. And we can position it the same way we did prior to that. Now, I've got the laser set to my thickness that I need. Now I'm ready to turn around this curve, and you may notice that the top of the laser is close to the multi-rest. It appears to me that it'll clear. If it doesn't clear, if you're concerned about it, you can always raise the laser up and go over the multi-rest. So I've got it set here. We'll try it and see what happens. If I need to adjust it, I'll adjust it. Okay, I've finished that curve around. Now I need to readjust my laser one more time to get the back wall and the foot, make sure I don't go through the walls there. Clean out what little shavings are in there. Reset the laser. Now, because I'm cutting basically on this edge, that's where I want to position the laser. And bring it out. Again, using the handy little card to get my wall thickness set. Tighten it up, and we're ready to go to town. So again, working from the top down to keep the mass at the bottom to help support the wood. Okay, I think we're pretty close to done. Pull the tool out. Get the little shavings that are left out. Get a little flashlight where you can see in. Look inside, see what it looks like. That looks pretty doggone good. I typically don't sand the inside of my forms. I will sand a little bit on the underside of the lip if needed. And this one, I've done a pretty good job for once, and I don't think it really needs it. So that takes care of the hollowing end. Now we're ready to move on. Finish the opening to accept the lid, sand it, get it ready to reverse chuck in the vacuum chuck, cut the bottom off, and then we'll be done. All right, now I've taken the hollowing system off. I've left the steady rest on, and I'll leave that on until I finish up what I'm going to do next. First thing I'm going to do, I've got a little bit of a lip coming up there. I want to get rid of that. Then I'll take a tool and I'll cut a rabbet in there for my lid to set in, a slight recess. And then I'll proceed to doing a little more turning on the bottom, and we'll go from there. All right, now I've flattened that out, and the reason I did, there was a little bit of a curve up there. The way I do my lids, I like to have that more flat to make my transition into my lid where it turns up. So I've got that done. Now I'll work on my rabbet. You can use a parting tool for that. I typically use a little square skew that a friend of mine made me that works really well. So I'll go ahead and do that. I'll trim up my opening, make sure I've got a nice square inlet, and then I'll cut the rabbet. Nice squealing noise. Now, I typically try to make my recess roughly half of the thickness of the wood. If you get that recess too shallow, the portion on your lid that fits in there can be difficult to get done because it's so thin it'll tend to break, can break off and cause problems. So that takes care of that part of it. So now we'll get rid of the tool rest, get rid of the multi-rest, and continue on with finishing our form on the outside. Then we can reverse chuck it and take the foot off, and we'll have that part done. I've shaped the foot a little bit more, got my form a little better here. Now I'm ready to sand. It's always important to have dust collection and or breathing mask or both. Wood dust can be harmful, believe it or not. So I typically will have a dust collector and a mask, but for this demo I'm only going to use a face shield and go from there. Typically, as I said before, I sand fast. I turn with the lathe fast and with the sander fast. So I'm going to go ahead and start the lathe, see what we're running at. I'm going to speed it up to That's up about 950 roughly. So I'll turn that fast, and I'll have my sander wide open. So we'll give that a shot and see where we go. And you always want to sand, even if it's a power sander or hand sanding. You always want to sand at about 7, 8 o'clock on the piece down here, because you're turning that direction. If you try to start up here, it's going to throw that sander back at you or throw your hand back at you, and that can hurt. So always make sure you're holding it down in the somewhere between 6 and 9 o'clock, and that'll give you a good easy sanding without causing you any problems. So I'm going to go a little bit farther here, and then I'll switch grits and keep moving my way up. You always want to wipe the piece down, either blow it off with compressed air or wipe it down to get rid of the previous grit paper that you used. So this one is not bad, so I'm going to switch and move up a grit and continue to work my way up through 600. Before you change grits also, just kind of look at the piece and make sure that you're not getting any excessive sanding marks, and that you're taking out the previous sanding marks, putting new sanding marks in, but getting rid of the older. And eventually, once you get up through all the grits, you won't have any sanding marks anymore. 20. Another way to wipe the dust off is use the back of your sanding pad. Again, I always look at it, make sure that I don't have anything that I need to get rid of, because once you go through the grits, if you find a place that you need to go back to. You got to go through all the grits again. That appears to be the wood, so we'll keep going. Sometimes it's difficult to tell with the wood grain whether it's sanding marks or the wood grain. And I think that's the wood grain there. So that's pretty much the end of the sanding, except for the bottom when we take that off. But I don't know how well it shows up on the video, but you can tell it's got kind of a nice sheen to it already. And when we get the finish on there, it should hopefully really pop and show the curl and show the figure in the wood. So now I'm ready to reverse chuck it, reverse mount it with the vacuum chuck and take off the foot, get the foot the right size. I'm a small foot kind of guy, so you can make that foot whatever looks proportional to your turning. So I'll get the vacuum chuck set up and we'll take that off and we'll be done with this part of it. Alright, I've got my vacuum chuck hooked up. There's several products out there, methods to hook them up. They're not hard to find on the website. The way I reverse it is I leave my chuck on the piece, and there's several of these adapters out there as well. There's some that rotate, that you can put it in your, first you screw this in your chuck. So when you buy one, you got to make sure it fits your threads. Then you simply mount it in your tailstock. What I've found is that the ones that allow you to rotate the piece aren't as steady and stiff as the solid piece that doesn't allow you to turn it. So you get a lot better squared up when you bring it up to the vacuum chuck. And you don't have any, you have a little bit, but that's fine, but you don't have a massive amount of being off center. So I've got that up, tighten the tailstock, bring the tailstock up a little bit, and turn the vacuum pump on. The vacuum chuck has a pressure gauge on it, so you can see what kind of vacuum you're drawing. Sometimes air will leak through the wood if you've got it thin, and quite honestly I'm getting some leakage here, and I'm only drawing about 8 or 10 pounds of pressure. I want to get rid of that. There's several methods of getting rid of it. One is you can take some plastic, wrap around it and tape on it, or two is you use, I use painter's tape. Expensive, but I'll wrap it in painter's tape and that'll bring allow you to get pressure. Other thing, as you turn, that dust will fill up some of the cracks on the bottom and allow it to get more pressure. Alright, I think I'm going to go ahead and put painter's tape on here, see if I can get the pressure, holding pressure up a little bit more, and then get rid of the chuck. And this doesn't need to be pretty, so just needs to help seal the wood, seal any leaks, and get the holding pressure up a little more. See that right there, that brought it up about 4 pounds. So we'll go ahead and put a few more strips around it. I don't want to go down too far because this area I'll have to blend in. I just want it high enough pressure. We're up to about 12 or 14 now. And you can feel, when you hold your hand up to it, the cold air being drawn through the wood. That's part of the issues with turning too thin. Okay, we're up to about 14 pounds, so we'll start there. If we need to put a little more on, we will as we go on, but the first thing to do is get rid of the chuck. And you simply loosen your chuck. Now your piece is held on there by the vacuum. The next thing you want to do is get to your live center. So we'll get our live center, put it in. Again, use the live center as long as you can because it's just more added protection to keep the piece from coming off the lathe. Alright, I've got the piece taped off, got our pressure up enough to hold it for now with the tailstock up, which gives the added support and makes it a little less scary than just having the vacuum chuck on it. You don't have any chance of losing the piece at this point. I go ahead and leave the vacuum chuck on, or the vacuum pump on, just to add that little extra support to the piece. So let me get going and get that foot turned off. And I don't know that the camera picks it up, but we got it on there and it is just almost virtually perfectly recentered, which is nice. At this point, you don't need to be real aggressive on your cuts because it does give it a chance of a catch, and at this point, you don't want to have a catch. All right, at this point I want to choose my size of my base, and with this piece I think I'm pretty good right there, so I'm going to start with parting tool and I won't cut this tenon all the way off, but I'll cut it back some, and I'll start my cut in. I'll go in at an angle so it'll be a concave cut and the piece will set flat. Again, I'm going to leave the live center, and I'm going to leave this tenon that's here on there as long as I can. So now I'm going to clean up this area that I just roughed out and blend that in, make sure it's a nice smooth continuation of the curve from the top to the bottom. Great. Now, the other thing on the bottom where the piece goes under, it's always good to put a little curve under there. You don't want the piece straight down into the tabletop because it looks like it's coming out of the tabletop, to be quite honest. And if you just put a slight curve on that bottom edge, it'll give it that lift and almost make it look like it's floating. Alright, now I'll cut some more on this tenon. Okay, now at this point I want to go ahead and sand this through the same grits that I did on the top part of it and sand over to that foot. That way, if by chance I have any trouble with this tenon when I start to take it off, I can clean that bottom up by hand if I need to. So, but I do want to go ahead and get this sanded, blended in nicely. So we'll go ahead and do that. Make a little more mess. Get the tool rest well out of the way, everything else out of the way. Now it's important to go through the same grits that you used on the top part, so it'll blend nicely into the, there won't be a break in your sanding. And I'm going to take a couple of pieces of this tape off and sand a little higher because I was hitting some of that tape. Okay. That's 600. My sander appears to be on its last leg, which is fine. I always have a spare. So now we've got that sanded. Now we're ready to cut the tenon off, finish the bottom, sand it. I always sand it the same grits I sand the rest of it, using the same sander, which is on its last leg. So now we're ready to cut the tenon off the bottom. Again, I use a parting tool. Success, and it's held on, and I've got enough pressure on it now, I think, where I can use a tool. Here again, I use a round carbide cutter to do this step with. Because it's easy to do. Again, taking light cuts. Okay. Now all we need to do is sand the bottom. And you always want your foot to look as good as possible, so you want to finish it just like you finish the rest of the piece, because most people, when they pick it up, are going to look at the bottom first thing. All right, we're up to 600 grit now. Now I always inspect it, make sure I don't have any flaws on the bottom. You can always add a couple of circles or some other kind of decoration on the bottom if you want. Always leave yourself enough room to sign the work. You don't want to put work out there with signing it. You need to do it, you're proud of it, you need to make sure you sign it. So now we're ready to turn the vacuum chuck off. And now we've got our hollow form done. We're ready to finish that part, but first I will do the lid. The next thing will be the lid, how I do it, and then turn the finial. And then the last step will be putting the 10-minute finish on it. So that's where we are. Okay, we've finished the hollow form, the vessel. Now we're going to turn the lid to fit the opening on the vessel, and do that. Let me set this back here momentarily. If you set it up here, it might vibrate off, and then you'll end up starting all over again. African blackwood is what I will typically use. I have used the same material as the hollow vessel. but this time I'm going to use African blackwood. Blackwood is much easier to turn than ebony, plus it's a little less costly, but it doesn't have the brittleness that ebony has, so it doesn't tend to crack and come apart. So I'll get started by turning the blackwood round, and then we'll move on to the next step. And here you can use any tool you're comfortable with. We're almost there. Close. Now I will just kind of square up the end. Doesn't have to be accurate, I just like to get it squared off, because if that end's not square, it tends to throw my eye off on the shadows in there, throw my eye off, and just it kind of messes me up, to be quite honest. So I always square that off. Doesn't have to be perfect. So now we're ready to do the next step, which is to measure the inside opening of the vessel. And again, this doesn't have to be exact. It's basically a guide. And then I just get an idea of how big that opening needs to be there. So I'll turn that down. And again, you can use any number of tools. I typically like to use a carbide cutter because it makes a good clean cut in this case. I'm not too worried about the length of it at this point. We'll get to that in the bottom of that when I get to that point. So we'll now I'll bring out one other thing. If you set your piece on the bed of the lathe, be careful, because you don't want to knock it off again. But at this step, I need to test fit as I turn this to make sure it fits in the vessel, and I get a good, hopefully snug fit. And I'll stop quite a bit to give me an idea of where I'm at. Stick the calipers up there. And cutting this lid is probably the slowest part of everything. I've still got a little ways to go, and then I'll test fit. Still take a little more. Now, I've tried doing this with calipers only, and for me anyway, it just doesn't seem to work as well. Okay, I'm in good shape there. Probably more. It's probably loose at this point. No, that's doing good because I've tapered it. So now what I need to do is just take a little more off on the top part. I've got a good fit there. So now what I'll do is just take a little bit of sandpaper and go ahead and sand that portion of it a little bit. I'll probably test it again. Then I will start on the top part to fit into our recess. And I basically do it the same way with test fit. Again, just trying to clean that up, make sure we got a nice smooth surface. Alright, we got that done. Now we're ready to move on to fit the top part that fits into the recess. Basically, I do that the same way. And measure that opening diameter. I'll put it up there, give me an idea of where I need to go to. Don't need to take off that much. Alright, as I've said, I always want to test fit, and I want to sneak up on it and make sure I get a good fit. Typically I'll put the calipers up there and that tells me yes, I'm not there yet, but I'll still put the piece up there, make sure. I've still got a ways to go, so come back over and continue to cut. And again, I always want to stop and check because I don't want to take off too much. Still got a ways to go. Because of the old saying, you can always cut more wood off, but it's hard to put it back on. See if I'm getting close, and I'm getting close, but I still need to take off a little bit. And I know I'm getting close. so I tend to check it more the closer I get to it. Yeah, I think we're there. Go ahead and sand a little more. And I'll go on up through the grits. Get it as smooth as I can get it. And if you do a good job of sanding, you don't really need any kind of finish on the black wood. You can typically go, sometimes I'll put a coat of the oil on it, but it really doesn't add that much. So typically you can go straight to the buffer with this. Yep, I think that's good. Okay, so now what I'm going to do is clean up the bottom portion of the lid. And you can add decoration there if you want. You can cut some lines if you want. I've gone to a little surprise that I put under there, which is just a little added feature. When you pull the lid off, there's something there that gets your attention. So I'll go ahead and cut the bottom. I want to get rid of that little nib in the middle. So now I'll go ahead and sand that off. And then we'll be ready to start on the top of the lid. Again, working up through the grits, cleaning off after every grit. Now at this point you want to make sure that you got all your sanding done that you're going to do on this lid on this end of it, because you won't be able to come back and do it again. Alright, now I've got the bottom portion done. I'm going to go ahead and do another test fit, and that's about as good as it can get. At this point I'll hold it on there and I'll draw a line around the piece that will tell me where I need to cut to for my lid thickness. Make sure I get a good smooth fit. So now I'm ready to start cutting on the top of it. Basically I'll start out getting rid of the excess wood. And the farther I go here, the more vibration noise you'll hear because I'm losing my support wood in this area. I want to make sure that I don't cut past my pencil line, or I'll have to start over again. Again, I know that I want to, where the form meets the lid, I want a nice smooth transition. So I'll kind of check my curve, just eyeball it to see if it looks like it's coming up the way it needs to come, and it's going pretty good. I'll still refine that as I cut in. As I narrow the top down, I know that I need to have a little less curve on the outside edge, so I'll try to flatten that down some. And you want to make light cuts. You don't want to make heavy cuts because it could snap the piece out of there or off of the chuck plate or the chuck. And I know we've got a lot more wood here than we need, because that'll go down to about an 1/8 inch or so. So again, I'll continually check and see how I'm doing. And I'm doing pretty well there. So I'll continue to work down on my pencil line. Check it one more time. Should be there. A little bit of edge there, but we'll get rid of that when we sand the top. So now I'm ready to kind of get it to the point to where we can part it off. And in our next step, we'll turn it around and do the top part of the lid. And again, the goal is to have a nice continuous curve coming up out of the vessel itself. Okay, still need to take a little bit more off. Okay, now we're ready to part it off and reverse chuck it, I think, and continue and clean up, get the top ready to go. Oh, need to part it off. And I always part it off longer than I want it. Okay, that's where we are at this point. We don't need that anymore. Don't need to take a chance on knocking it off. So now we need to take this chuck off. And what I've found works really well, I use nylon jaws to actually do the top portion of it. The great thing about the nylon jaws is they don't mar your wood. If you use regular jaws, it'll definitely mark your wood when you tighten down on it. The nylon jaws, you can cut to whatever you need, and I think I'm going to have to do some cutting on these to fit. Maybe not. No, that'll hold there. So I check it, make sure it's on center, and it's on center. So you have to take light cuts with these because they don't hold quite as tight as the regular steel jaws do, and they don't have the teeth to bite into the wood. So you, as I say, you need to take light cuts, and so we'll do that, then we'll sand it and drill the hole for the finial. And of course now we don't have the chatter that we had before because we've got it well supported, so you can clean up any marks that you need to. Kind of checking that curve. Taking that diameter down. Now at this point, I want to go ahead and drill my hole for my finial. That way I've got that hole as a guide as to how thin I get it at that point. We just slowly Slowly drill in. Now we've got our hole all set for our finial. So now we can go ahead and continue cleaning up. I see a couple of chatter marks there, so I'll need to get rid of those. And again, very light cuts. Just a hair more cleanup there. Light cuts, okay. Now we can take it out of the jaws. Now, so now I've test fit the piece. I kind of look at it from the side, and I think our curve's good, and I think our height's good. So now I'll take it off, which I've got a good fit. So I need a little help getting it out, so I'll take the drill bit. Put it in the hole, and that will give me enough, hopefully, to get the lid out. Sometimes that black wood, when it gets hot, will freeze up in the bit. So got that done, so I'll just stick the bit down in the hole, and that should give me enough grip to get the piece out of the, get the lid out of the piece. Yeah, there we go. So now I can remount it. And amazingly enough, these always end up recentered better than in a normal set of jaws. So now I'll sand the top of the lid, and that should finish it. Get the right grit of paper that I want to start with. I'm starting with 240. And need a little more right there at the top. Now, it never hurts to go, although they say that the eye can't see marks after, I can't remember the exact grit, but if you want, you can go 800. You can use micro mesh and go up to 12,000 and get a nice shine on it if you want. Typically, I'll go through the 600 and stop. And okay, I think we're finished sanding. Everything looks good. So now I want to take the lid out of the jaws. Just grab my vessel, make one final test fit. Got a nice snap fit to it. The edges look good. The curves look good. So now we're ready to take that out, move on to our finial. All right, I've now mounted my finial blank in my jaws, and I use the short pin jaws. I found that they actually seem to hold better than the long pin jaws. The other thing I found out that helps in the holding is when you're using a blank, whether it's a pencil blank or one that you've cut, make sure it's square. That way you get good contact all around the base, and it will hold better. Also, with my type of finials, I'm able to use the tailstock for support, so I don't have to start at one end and work my way down and sand as I go. I can do all that at the end. The one thing I've learned as well is to get the height of your finial or the length of your finial. I typically use the golden mean rule and want the finial to be about 2/3 the height of the vessel itself. Now that is not really a hard fast rule. Some finials look good taller than the vessel, some look better short, but that's always a good starting point. What I do is I've got a box full of finials that I've turned and not used or turned and didn't like, but what it allows me to do is take those finials and I can hold it up to the vessel that I'm working on, and I'm able to get a good idea of what length that finial needs to be. I've got several with me that I can hold up there and just be able to judge the height of what I think looks good. I think that one's maybe a little short. I think that one, just appearance-wise, is short, and I can tell it by holding it next to the body. So that's a little short. There's one I dropped on the floor, and it actually, to my eye, looks pretty good to the height that it needs to be. So what I'll do is take that and allowing room for the top, because I'll end up putting an angle cut on the top of the finial, and I'll just simply make a mark as to how tall that piece needs to be. So now I'm ready to start rounding the piece. Get the blank round. Now I use a 3/8 spindle gouge for turning my finials. I've got 2 or 3 of them because sometimes I'll pick one up and it just doesn't seem to cut like I want to, so I'll switch to another one. And it'll end up cutting fine. So I'll go back and forth depending on how I'm cutting at the time. So I've got the piece round, so now I'm ready to start taking it down to the pretty close to the finished diameter. So we just keep going. This is slow work. You can't get in a rush on a finial, or you will end up breaking it off, having to start again. And any ridges little ridges will sand off. So you want it as smooth as you can get it, but okay, I've got my basic rough shape out. I'll come back and thin that up. Now what I want to do is work on my ball, because I want this extra support here to where it doesn't flex and end up snapping off. So next thing I'll do is turn the little ball on the bottom. Basically what I do is turn the cylinder to about the diameter that I think I'll make the ball on the bottom of the top part. And then it's basically turning two coves. Basically you want to center it, roll over and around. It doesn't hurt to start out a little big in case you don't get it the way you want it. Bring that side around. I'm going to switch to safety glasses at this point. Finials, you need to see a little better, and if with the mask it's a little more difficult to see the details. So typically on these I'll switch to safety glasses, because if something comes off, sure, it can hurt you a little bit, but it won't kill you. I'm just trying to get the basic shape the way I want it. Okay. Alright, I think I've got that pretty much where I want it. The size I want. I can take it down a little bit more. But so now I'll go back to the top part of the finial and try to refine it down. And it can be a slow process. But again, I'll keep the bottom part where it's meeting the ball fairly thick and thin down. Judge where I want the thickness to be. Get your cuts as clean as you can get them. Okay, that's pretty good there. So now I'll go to sanding. Start with whatever grit you feel is needed. This time I'm actually starting with 120 grit because I had some pretty good ridges in there, and I want to get rid of those. You be careful when you're sanding though, because the smaller the piece, the more wood your paper will take off, so it's real easy to get it thinner than you want. So I'll clean that off, go on up to 120 and work my way up through the grits. and 600. Okay, that looks pretty good. So now we'll go back to finishing up the ball portion. And again, it's basically 2 beads, or 1 bead actually, makes a ball. Now I'm actually not going to take this end with the little tenon that'll fit in the lid down very far at this point. What I'll do now is take the top part of the finial, because you never can sand square, and just get it into the top of the ball with a nice sharp corner. Then I'll continue making the ball. And I take off very little with my cuts, because I've got it pretty round. And sometimes I'll make this the shape of the form. Sometimes I'll just go with a round ball. Depends on my mood that day. Again, I try to get a good sharp corner where it meets the top part of the finial. And then, again, just working the ball, trying to get the diameter to where it looks round. Again, this can be pretty delicate work. What I want to do is get the bottom around and stop to where it's approximate diameter of the top of the lid, so there's not a void there where the ball meets the lid. It comes down and is flat. So now I'll do a little sanding on the ball. Got a couple little marks in there that I need to get rid of. Okay. Again, work through the grits. Okay. Okay, that's pretty good. So now I'll come back and finish the bottom of the ball. Like I say, I can see that I need to take a little bit more off of the one edge to get it a little rounder. That looks pretty good. So now I'll switch to the parting tool, just checking to make sure everything is satisfactory. Typically I'll use my standard 1/8 inch parting tool. When I get down close to where I need to be, I'll switch to my small narrow parting tool. And again, I need to go to the calipers just to get an idea of where I'm at. And even though I know that this was a certain diameter drill bit, I always kind of like to measure the hole, and it kind of gives you make sure that you'll fit in your opening. So now I'll just start parting off. And again, I'll leave a little flat spot on the bottom of the ball so it doesn't leave a gap when it's mounted on the lid. So with delicate touch you can make small corrections. I'll just sand that off a little bit. See how we're doing. Not too bad. Alright, so now I'm ready to part it off. Always disconnect or get rid of the tailstock so it doesn't get caught and start flapping around, break. And just simply hold. Always be careful with your sleeves and clothing. Keep them well away from everything. So I'll just use my small parting tool and part it off. Now we're almost finished. At this point I always set it in the piece, make sure it fits, make sure it looks good. Now it's too tall now, and that's fine because I'm going to cut the top part off at an angle. So I'll kind of judge that height again. It's a matter of personal taste, but I think it will look best, probably about where my thumb is, so I'll mark that. Set this aside. Take my pencil and I'll just put a mark on there. And it's always easy if you're a little long to come back and shorten it, but it's difficult to add it back on. So now what I'll do is go to the bandsaw and I'll simply cut that off at the angle that I typically have. There's nothing scientific about it. Just get that wood out of there. I've gone to the bandsaw and simply cut an angle off the top of the finial at the proper length, what I felt was a proper length. The precise angle, it's not precise work, just cut it what you feel like cutting it at, 45, 60, it doesn't really matter. Then what I do is take it to the oscillating spindle sander and simply hold it up against the spindle, and it'll sand that smooth, get rid of all your saw marks with your bandsaw. So now we've got that done, we've got all our pieces done, fit together, so now we're ready to do the finish. Now what I use is Minwax antique oil finish in the red can. You don't want to follow the instructions on the can. It'll mess you up on this particular finish. This is a finish that I basically was just playing around, experimenting, and I found this, that it works, and it allows me to finish a piece with a nice soft shine piece that allows me to feel the wood. And I like that in a finish, that it feels like wood, it doesn't feel like glass. Certain pieces require a glass finish to look good, and so I'm not against them, but most of what I turn I want to be able to pick up and feel it and have it feel like wood. Basically where I start at this point, I will have signed the piece. I'll either use a burning pen or an etching engraver pen to do it. So once I've got that done, now I'm ready to apply the finish. And this is where you don't want to follow the instructions, because they'll have you put this oil on and let it set globbed up like this. And the secret to this is you don't want to do that. And you basically want to rub the oil into the piece. And you want to end up with none left on the surface. So you can start on the top, on the bottom, it doesn't matter. And simply rub the oil into the piece. And you will get it on your hands some, but that's all right. We all like to get dirty, don't we? You just want to make sure you've got the piece covered with the oil, rubbing it in. And the oil will really make your grain pop when it's finished. So I've got that in. I'll come back with a dry rag and get some of the excess off. Because you don't want any globs of oil. You want it all off to where it basically will feel somewhat tacky, but that's all right. Okay, so that piece is ready for the next step. I'm going to go ahead and put a little oil on the finial and lid just to kind of shine them up a little bit. Again, don't rub it in, wipe it off, put it on and wipe it off. You can lay it on your workbench, on your tabletop. It's not going to hurt anything. Again, rub it in. You don't want to end up with any globs left. Rub it in, rub it off. All right. Now it's got just a little tacky feel to it, but not bad. So now we are ready to go to the buffer. I use the Be-All buffing wheels. I know there's other products out there and other wheels out there. So use whatever you have. So now we're ready to buff it, and then we'll glue the finial on. All right, I've got my buffing wheels mounted. This is a little system that has all 3 wheels on it that you can use on your lathe, which is handy. It's not real good for huge pieces, but if you've got a standalone buffer, that works just as well. I don't use the white diamond wheel anymore. It tends to leave a residue in any small crack or crevice. Even a little check mark can leave residue in it. So I don't use the white diamond wheel anymore. When using a buffer, you want a slower speed. You don't want to run it at 3,000 RPM because you'll get too much heat. Typically, most standalone buffers are at 1725 RPM. The other thing is that it doesn't take much of the triple E or the wax to finish a piece. If you load that wheel up, that in turn will gum up on your piece and you'll end up with a mess. So it doesn't take but a touch of the wax and triple E bars to get where you need to be. So get my safety glasses on, and first I use the triple E, and as I said, it doesn't take much. That's typically about all you need to put on there. And then start buffing. Always buff on the bottom portion of the wheel. There's a lot less chance of grabbing there. And always hold on good and tight. Don't hold it loosely because it can go. Let's see, I'm running a little slower than I want to be. So I'm going to speed it up. And you remember now, this just had the oil put on it a few minutes ago. And I'll generally go over it a couple of times, just make sure I haven't missed any spots. Now, if you want to finish the inside, that's fine. Of course, you can't buff it. Most of the time, I don't finish the inside. Have never had any issues not finishing it. Look the piece over. Don't see any missed spots. Now I go straight to the wax wheel. Again, just a touch. Now I put the wax, the same procedure that I used the Triple E. And the Triple E has a very, very mild abrasive. Okay, we've got that done. Now we need to do the lid and the finial. And the lid and the finial are a little trickier because they're smaller and take a little better grip. But you basically want to do them the same way. You just got to be a little more careful, because they'll sneak out of your hand before you even know it if you're not careful. And then once you find them, they'll usually be damaged. Okay, that looks good, so I'll switch over to the wax. Should give them a nice shine. Go ahead and wax the bottom of that. That looks good. That's the lid finished. And now typically the most dangerous one is the finial. People say, well, do you buff those? Yes, you buff them. You just have to be very careful, because they'll sneak away from you before you can even blink an eye. So do the Triple E just like the other. Kind of do it out toward the edge of the wheel where it'll get down in the small spots, and then I'll just hold it on both ends and kind of work it up the finial. And I'll turn it around and do the bottom of the finial. And that's pretty good. So now I'll switch over to the wax wheel and do the same thing. Kind of working the edges, get that wax down in the corners. And then just lightly, again, no pressure. If you push it in there, you're either going to break it or you'll have a good chance of grabbing it. Turn it around, do that part, and it doesn't hurt to get your fingers on the wheel. You can let your wife come out to the shop and buff her nails if she wants, which might be a pretty good thing to do. At least it could get her out there. So that's it on the finish, and it goes very quickly, gives you a nice soft shine to it. You can actually feel it, and feels like you're holding woods. If there's any inclusions or any little, you can feel everything. So now we've got that done. All we've got left to do is mount the finial. Okay, we finished our buffing. I've taken the buffing wheel off the lathe. All we really have left to do is to glue the finial on. I use any brand of what I call super glue will work. People don't call it that anymore. But basically what it takes is doesn't take much, small drop on the end of the finial, and then I'll typically get down to where I can see if it's straight Drop the finial into the hole. Make sure it looks perfectly vertical. And let it set and dry. Typically you'll be able to use that ball to get the lid off. You don't want to pull from up here to get the lid off, but it'll allow you to work it off once it's set up good and dry. If it comes out, you typically re-glue it. It's no big deal. So, all right, I think we're finished with the project. We've got our finial glued on. Looks to be good and straight, so had a great time here at Carter Products filming this video. Again, my name's Keith Burns from Collierville, Tennessee. Feel free to get a hold of me at any time if I can help with anything. Hopefully you've picked up a trick or two today. So thanks for joining us.